You ever get that little shiver when a cool breeze hits? Ever wonder what's really going on there? Well, it's not just, a minor inconvenience. That's actually the first shot being fired in a constant, invisible war your body is fighting to keep you alive. So let's pull back the curtain on this incredible, high-stakes battle for warmth.
It sounds like a pretty weird connection, doesn't it? A simple, everyday shiver and a super complex medical treatment. But believe it or not, they're two sides of the exact same coin. Today, we're going to pull on that thread and see exactly where it takes us.
All right, so to really get this, we've got to meet the general in charge, right? The little part of you that's running this whole show. Okay, so deep inside your brain, there's this tiny but, super powerful region called the hypothalamus. You can literally think of it as mission control for your body's temperature. It is constantly monitoring your core temp, and if it senses even a tiny little drop, boom, it sounds the alarm and kicks off a whole chain of defensive measures. And the first, most obvious defense it deploys? Yep, shivering. Now, scientists call this shivering thermogenesis, which is a fancy way of saying making heat by shivering. But the key word here, and you really got to remember this, is involuntary. Like, you're not choosing to do this. Your hypothalamus just flips a switch and your muscles start spasming over and over for one reason and one reason only, to generate heat.
And look, you can't underestimate how powerful this is. We're not talking about some minor twitching here. When it's really going for it, shivering can crank up your body's heat production by up to a whopping 5 times its normal resting rate. It's like your body just decided to turn on this massive internal furnace all by itself.
Okay, but a furnace that powerful needs a ton of fuel, right? So where's the body getting all this energy for these crazy intense muscle contractions?
Your body needs a fuel source that's not just powerful, but it's got to be right there ready to go, like now. It can't afford to wait for you to digest a sandwich. Turns out, the answer is already stockpiled right where the action is happening.
And that fuel is something called glycogen. Now, you can just think of it as these tightly packed bundles of sugar, of glucose, that are stored directly inside your muscles. So when that start shivering command comes from the brain, your muscle cells can immediately start breaking down this glycogen to create ATP. ATP is basically the tiny rechargeable battery that powers every single thing your cells do. And shivering just shreds through these batteries at an unbelievable pace.
All right, so the fuel is glycogen. Simple enough. But, and this is where it gets really, really cool, it's not just about having the fuel. Where that fuel is located inside the muscle cell, that is everything.
So when scientists looked under these super powerful microscopes, they saw that glycogen isn't just floating around randomly. It's neatly organized into different storage pools. There's some under the cell wall, some packed in between the muscle fibers, but the real VIP, the one that matters most, is the intramyofibrillary pool. It's sitting right next to the little engines that actually make the muscle contract. And a quote from the research just hits the nail on the head. It tells us that when your muscles get tired and the shivering starts to fail, it's not because the whole muscle is out of fuel. Nope. It's because that one specific, strategically placed fuel tank, that intramyofibrillary one, has run dry. The engine sputters, even if there's still gas in other tanks around the cell. Location is everything.
And here's a pretty fascinating little side note on how our bodies use fuel. Basically, studies have shown that, on average, men tend to burn through their carbs, like that glycogen we were just talking about, a lot faster during exercise. Women, on the other hand, tend to be a bit better at using fat as an energy source. It's just a subtle but really interesting difference in our basic metabolic wiring.
But here's the thing, this amazing internal furnace, it's not foolproof, it's not invincible. And when you push past those limits, when the fuel runs out and the cold just keeps coming, that's when the body's whole battle plan starts to completely unravel. And this is when things go from just being uncomfortable to being genuinely life-threatening.
And this is the terrifying progression of hypothermia. In the beginning, the mild stage, your body is fighting like hell. The shivering is intense, almost violent. But your brain is already getting hit. Confusion starts to creep in. But then, as you slip into the moderate stage, something really scary happens. The shivering might actually stop, and that is not good news. It doesn't mean you're warming up. It means the system is failing. Your body is running out of that easy access fuel. Speech gets slurred. You get clumsy. By the time it's severe, the body is losing the war, shutting down core functions, and leading to unconsciousness and a huge risk of the heart just stopping.
And look, this isn't just some textbook theory. This is real. This data shows the tragic reality. The danger of dying from hypothermia skyrockets as we get older. Why? Because all those amazing systems we've been talking about, detecting the cold, firing up that powerful shiver, they just don't work as well over time. It makes the elderly incredibly vulnerable to a threat their bodies used to fight off with ease.
Okay, so if you thought it couldn't get any worse, well, this is where the story goes from tragic to just plain weird. Because in the absolute final stages of severe hypothermia, the body's systems don't just fail, they start to malfunction in some profoundly strange and counterintuitive ways.
Remember our mission control, the hypothalamus? Well, as the core temperature just plummets, that master thermostat basically starts to glitch out. It's sending corrupted files. The whole organized defense against the cold just devolves into total chaos, and it leads to behaviors that make absolutely no sense and actually speed up the end. And this leads to two of the most chilling, well-documented phenomena: paradoxical undressing and terminal burrowing. First, paradoxical undressing. The person, who is literally freezing to death, is suddenly overwhelmed by a feeling of intense, burning heat, and they start tearing their clothes off. The theory is that either the hypothalamus has just totally malfunctioned, or the tiny muscles that control blood flow give out, sending a final, deceptive rush of warm blood to the skin. And this is often followed by terminal burrowing. It's like a deep primal instinct kicks in, the same one that tells a hibernating animal to find a small, safe space to hide, and victims are often found in tight spaces like closets or under beds.
So, okay, up to this point, cold has been the villain of our story, right? The enemy. But now we're going to flip this entire script on its head. Because in the world of modern medicine, cold isn't just a killer, it can be a powerful tool for healing.
And this really is the central paradox of this whole thing. We just went through in detail how deadly a drop in body temperature can be. So why in the world would a doctor intentionally make someone cold? The answer is, it's a calculated risk to protect our most precious and most fragile organ, the brain. The procedure is called therapeutic hypothermia. After something awful like a cardiac arrest or a bad head injury, a destructive chain reaction of chemical processes can start in the brain. By intentionally cooling the body, doctors can slow the brain's metabolism way down. Think of it like putting the brain into a low-power hibernation mode. It buys precious time and stops that chain reaction of damage. In this race against the clock, cold is the brake pedal.
So this sets up this incredible, high-stakes battle right there inside the patient's body. On one team, you've got the doctors, trying to keep the body cool to save the brain. And on the other team, you have billions of years of evolution screaming through the body's survival instincts that this cold is a deadly threat, and it's about to unleash its #1 weapon, the shiver.
So to make this treatment work, doctors literally have to hack the body's shiver response. And they do it with a really clever two-part strategy. First, they use a cocktail of drugs that basically raises the shivering threshold. It tells the hypothalamus, hey, calm down, it's not as cold as you think. And then part two is this really smart physical trick. They use things like warm air blankets, not to warm the patient's core, but just to warm their skin. This tricks the skin's sensors into sending, hey, we're warm out here, signals back to the brain, which helps to shut down that shiver command even while the core stays therapeutically cool.
So just think about the journey we've been on here. We started with a simple, automatic shiver powered by these tiny, perfectly placed fuel depots inside our muscles. And we ended with a cutting-edge medical procedure that has to actively fight against our body's most fundamental survival instinct, just to save us. It leaves you with this one big question, right? Our bodies are equipped with these powerful, ancient instincts designed for one thing, survival. But what does it really mean when modern medicine has become so advanced that sometimes, to save a life, we have to find a way to outsmart survival itself?